Alrighty, on we go. So we last talked about compound interest, and we talked about present value versus future value, which is all super accurate, good stuff. Um, the reality is, however, when most people invest, if you need $50,000 for a down payment in you know 10 years when you go to buy your first home, you're probably not going to put one lump sum away right now and just hope that it gets big enough in 10 years. The reality is virtually everyone is going to be paying chunks at a time, making regular payments. And so regular payments are calculated differently. Now, we used to calculate these by hand. If we were at school, we would be using the graphing calculators to do this. However, we are at home, so we don't have, most of us at least, a graphing calculator. So I have linked in this lesson where I posted the lesson on Google Classroom, I have linked a web page that does it's called TVM solver. It's the time value of money solver, and it lets us do calculations revolving around making the use of payments, either to pay off a large loan or invest monthly to gather a large, or not necessarily monthly, with whatever frequency you would like, in order to end up with a large lump sum. And so those collectively are typically called annuities. But what we're going to talk about is we're going to talk about investments or borrowing. Ooh, that's terrible. Investments or borrowing, making use of payments. Okay. So if we think about all the different things that we're going to almost certainly need to make payments on in our lifetime, most of us, when we go to buy a car, will not save the 25, 35, 45, whatever $1,000 that we need to make a car. Most of us will borrow a large chunk of money and then make payments to pay the car off. Or if we are thinking, as I mentioned earlier, about saving money to make a down payment on a mortgage down payments need to be quite substantial, although the rules right now are 5% of the value of the home at a minimum needs to be put down. Personally, I'd always advocate to have 10% of the money to put down. But even if we go with 5%, if we think about the average cost of a home in Canada pushing $400,000, even starter homes are $300,000. That means at $300,000 for 5%, you'd need to save up $15,000 just to make your down payment to even get into a mortgage on a home. So there's lots of scenarios where we're going to need to put money away regularly. Another thing like that is I put money away monthly for my daughter's education in her RESP. And we're going to talk about different investment vehicles and how they're used, probably next week, but maybe the week after, depending on how long we spend on this. Probably next week. Anyways, we're going to get to that. So, what we're going to talk about is making payments. And the easiest way to do that is by looking at some examples. But I first want to kind of help you think about exactly what's going on. So imagine that from the time that Brianna was born until when she goes off to university. Now, I didn't do this. I was irresponsible. I didn't start until a little bit later. But imagine the following. So I invest $200 per month from when Bree, my daughter, was born until she goes away to university at age 18. I earn 7.5% interest per annum, and I'm going to say compounded monthly. How much will this be worth on her 18th birthday? So, I mean, if we absolutely 100% unequivocally needed to figure this out and we didn't have access to TVM solver, here's what you'd need to do. You'd have to think about these as each being their own investment. So the first $200 I put away, it gets to grow for the entire 18 years. And so you'd figure out what it's worth. And then the next month I put away $200 and it would grow for 17 years, 11 months, right? And you'd figure out what that's worth. And then there'd be 200 and it would only grow for 17 years and 10 months. And you'd take all of those and there'd be a whole truckload of those things and you'd add it up and the value at the end would be exactly how much money this investment was worth. Now, there are some formulas that we can use to calculate these things, but we don't do that in the 3M math class or in middle math. If you took 3U, university level math, in a normal year, I would expect you to have exposure to how to calculate that by hand. In this year, I bet we probably aren't even teaching that because it's kind of a secondary thing. However, this is really, really valuable information because this is very realistic information. This is the kind of thing that you need to know about and you need to be able to calculate because this is the real world. These are all reasonable numbers. Now, 17.5%, that's not a reasonable number if I was just putting it in a bank account or even in bonds. But I can tell you over the 11 years that I've been doing this for my daughter, I've actually averaged a little bit more than that. I've averaged about 8.2%. So I've done even better than that. So this is not an unrealistic number for an investment to happen, but it's not going to be just in a bank account. And again, we're going to talk about that probably starting next week. We'll see. So on to that web page that I linked off of the Google Classroom. This is what it looks like. Okay, this is what it looks like. And so you can see TVM calculator is what we're on, and that stands for the time value of money. And so this one is laid out very, very nicely. There's a field for present value. There is a field for payments. There is a field for future value. There's a field for annual rate as a percent. There's a field for periods. That's how many compounding periods there are. And then it's a field here for what the compounding frequency is. So these are all of the various compounding frequencies that we have access to. Okay, so we look at that and we're going to fill in everything. Now, there's one thing that I didn't stipulate, and it's end or beginning, and that has to do with when does the payment occur. So if I said I make monthly payments, do I put the monthly away on the first day of the month, or the payment away on the first day of the month, or on the last day of the month? Okay, and that makes a difference because if I put money away on January 1st and let it grow until December 31st, it grows for a full 12 months. If I put it away at the end of the month, that means that it actually has one fewer month that it grew. Okay, so back on this problem back here, I didn't explicitly stipulate, and I'm going to add this, I guess, investments or payments are made on the first of every month. So at the beginning. Okay, now it won't make an enormous difference, but it does make a difference, and we'll be able to see that pretty quickly. Okay, so I come back here and we say present value. Well, present value, if we think about it, that's how much money was in the account to start with. If I'm making payments like this, the present value is zero. There was nothing there to start with. So I'm going to put in zero. Payments. Well, we said that, I think I said, let me go check again, $200 per month. Yeah, $200 per month. So I'm making payments of 200. Future value. This is what I want. So the way that this web page works is you fill in all the bits you want and you leave the one that you, or sorry, all the bits that you have and you leave the one you want blank and it will solve for that. So the annual rate as a percentage was 7.5%. So I'm going to put in 7.5. The number of periods. Now, I don't know. I haven't actually played with this all this much. On the TI calculators, you can type in. So it's 18 years times 12. So I don't know if I can do 18 times 12. Let's check. 18. No, I can't do 18 times 12. So in your head or on a calculator, a different calculator, you can do 18 times 12. So that's going to be like 216, I think. But let me just check. So 18 times 12. Yeah, there we go, 216. So there's 216 periods that we're going to put money away. And I said the first of every month, so it's at the beginning, and compounding periods were monthly. So there are all of the fields. What's your guess? I'm not going to hit the solve quite yet. I'm going to put away $200 per month for 18 years at 7.5% interest. So let's do some napkin math on that. 200 a month. So that's like 2,400 a year that I'm putting away. So I'm going to put 2,400 away a year for 18 years. So 10 years is 24,000. So another 8 years is, like another 20ish thousand. So that's like $44,000 that I'm going to be putting into a bank account or into an investment. But the hope is that it's going to be a lot more than that because it's growing interest. So the difference is, of course, if I just put it in a coffee can and buried it in my backyard, all I would have were the exact number of dollars that I put away. But because I'm investing, it's going to earn interest. And remember, interest is the fee that the bank pays me for the privilege of using my money. So 44,000 ish is how much we, put away in real dollars when we solve. Now, it says negative 91,000. And that's a weird one. I don't know if I want to, like, it's negative 91,000 because I'm paying out. So it seems like it's negative. Basically, we can just ignore that sign there. So $91,488.36. That's a lot of money. So $91,488, $91,488.36 is how much will be in her account when she turns 18 to go off to university, which is good because, 4 or 5 years at university will eat the better part of that chunk of money if she's going away to school, which is, she's only 14. I don't know if she's gonna, but probably will. So that calculator did some pretty substantial calculation for us, but pretty cool that it can solve that for us. What's really interesting to experiment is how big a difference interest rates can make, and you can check that really really quickly. Imagine that instead I found an interest, like something that paid me 8.5%. I didn't get a different color. 8.5% interest, so only 1 more% interest. So imagine that, I did better. I found a different investment that paid 8.5% interest. And let's think about, what that would be. What's your guess? I know that if it was 7.5%, it was, $91,500. If we got 1 more% interest, is that going to make $100 difference? Is it going to make $500 difference? Is it going to make $1,000 difference? I don't know. But what's really cool is this web page lets us explore that really quickly. So I can go back to the web page and I can say, no, it's actually 8.5% interest, right? And then I can click on the FV again. Look at that, $102, $102,177.59, more than $10,000 more because I got 1% higher interest. What a difference, right? That's a huge difference. Okay, so this TVM calculator is really really cool. It lets us solve for any one of these things. which is really, really neat. Okay. And we're going to explore that. So we're going to do a few more of these. And again, I would like you on your own to follow this link. And please, 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 after I present the problem, go off to this TVM solver and enter all of the details in and see if you can solve for it. Because this is a real world tool that you have access to, and it lets you explore different scenarios really rapidly and accurately. These are not fake numbers. This is exactly what really is, right? And so, putting away $200 a month is a pretty common thing, not hugely common, but we're going to talk later why that's actually sort of a magical number, $200 a month, when we're talking about education investment. We're going to get to that. But yeah, really, really amazing. So more than $10,000 extra interest if we had an extra 1%, right? Amazing. Amazing. Okay, so we can use it to not only solve for how much we end up with, we can also let it solve to figure out what payments are going to be if I need to end up with a chunk of money or I need to pay a chunk of money off, any one of those things. Excuse me. Okay, so let's do another one just like that. So let's say when I turned 20, I began investing $50 per week into an account which earned a measly 7.2% interest per annum. Again, this one's going to be compounded weekly. I do this until the age of 40. How much is in the account at age 40? I invest at the end of every week. So go ahead, solve for how much do I have at the age of 40 when I get there. So 20 years later, if I put away $50 per week, that's 7.2% per annum, compounded weekly, and I do it till the age of 40. So, and I invest at the end of every week. So go ahead, pause this, pop out to that web page, and see if you can figure out what the total investment was worth at the end. Okay. Welcome back. So I'm going to go off and I'm going to start filling this thing out. So I am going to hit reset to clear this all out. So it says that I'm paying at the end of every week. So there it is, end of every week. Present value. I didn't start with anything, zero. Okay. Payments. How big are my payments? I said that I'm making payments of $50. Future value. It's what I want. I don't know. Annual interest rate. What was it? 7.2, I think I said. 7.2. 7.2. Periods. Okay, this is where I'm gonna have to do a little bit of calculation. There are 52 weeks in a year and I'm doing it weekly. So it's gonna be 52 times 20, which I can do in my head. 52 times 20. So like before I hit enter, it would be 1,040, I guess. Is that right? Yeah, 1,040. Okay, so number of periods is 1,040. And the compounding is, well, it is weekly. Okay, so what do we think that's going to be worth? I'm going to bet it's worth a fair chunk, right? Future value 116,151.18. So 116, 151. So 116, 151.18 is the total amount. Okay. So if I put away $50 a week, so $50 a week, think about like that seems like, oh, it's so much money. But let me tell you, once you start working, we squander our money on silly things, right? $50 a week. So if I ate out for lunch every day of the work week and I spent $10, so you go into Subway or you go into Wendy's, or you go anywhere pretty much, and you're going to drop 10 bucks on lunch. If you brown bag your lunch instead and use leftovers from the night before, you could save 50 bucks a week pretty easily, right? You put 50 bucks a week away, 7.2% per month or per annum is not an unreasonable investment amount. It's not at all. For 20 years, I ended up with $116,151. These are real numbers. These are not making up numbers. The amount of money that we blow on silly things can be staggering. And these tools let us reflect on just how bad those choices are and how much money we would have otherwise. Okay. So I'm going to add a follow up question to this. Okay. So here's my follow up question. I haven't done one like this yet, but I'm going to still ask you to try and do it on your own. So a follow up. How much interest did I earn? Okay. How much interest did I earn? So think about it. I put away a chunk of money. I ended up with that chunk of money. Obviously, it grew. How much money did I earn in interest? So pause it. Think if you know how to do it, give it a whirl. And if you don't, here we go. Here's how you would do it. Well, I'm putting away $50 per week. So the amount of money that I put away is the principal amount that I've put away, and it's not the interest. So I put away $50 per week. There are 52 weeks in a year, and I'm doing it for 20 years. Okay. So I'm going to grab my calculator because that's probably beyond. Actually, I bet I could do it in my head if I tried, but I'm not feeling it right now. Or am I feeling it? Yeah, I'm feeling it. So that's 100, that's 1,000. So it's like $52,000, but let's just check. So 50 times 52 times 20. Yay me, it's $52,000. So that means that I put away 52,000 of my own dollars into this investment. Well, the investment ended up being worth this much. The difference between how much I put away and how much is in there at the end is accounted for as interest. So the interest that I've earned, now interest as a rate is always lowercase I. That is a rate, right? Lowercase I is a rate. Uppercase I is interest dollars. Okay, so it's the actual money. So uppercase I here is going to be worth 116,151.18 minus 52,000, right? And I guess that would be $64,151.18. Okay, so by putting away 50 bucks a week for 20 years, that's 7.4% interest, I earned $64,000 in interest. Huge, huge numbers, right? And these are realistic numbers. There's the concept of time value of money. Money grows. The earlier you do it, the better it grows. Um, the best time to start investing was 10 years ago. The next best time to start investing is right now, right? So there are some kids I went to university with who were in the co-op program, and they started investing for their retirement even while they were in university. Now they were in a pretty fortunate position because they had other stuff covered, but nevertheless, the earlier we do things, the better. Let's look at how we can use this to figure out what our payments are going to be. So again, examples are where it's at. So red for the danger zone. I borrowed $161,500 for my mortgage. Okay, now that's actually real. I'm going to use some big words here and I'm going to describe them as we go, and we're going to talk about them more in a while. But I amortized over 20 years. So, what amortize means is mortgages are probably the biggest loan you're ever going to have in your life. And mortgages, when you get out a mortgage, most people take a mortgage for 25 years. So they're intending to pay it off over 25 years. Amortizing is, I'm going to be careful. This is the length to fully repay your mortgage. Okay, so if everything went according to plan and I didn't change anything else, I didn't borrow any extra money, I didn't miss any payments, I just kept on paying and the interest rate stayed the same, amortization is how long it takes to pay your mortgage off. So I borrowed $161,500 for my mortgage. I amortized over 20 years. My interest rate was 3.4% per annum, compounded semi-annually. I make, it's going to be a weird one here, bi-weekly payments. We're going to get into this again later, but I'll give you some insight right now. So there are lots of different ways you can pay your mortgage. You can pay your mortgage monthly, you can pay it weekly, you can pay it semi-monthly, you can pay it bi-weekly, and those two sound almost the same. There are lots of different ways to pay your mortgage. My advice to you is set up your mortgage payments to coincide, to happen at pretty much the same time that you get paid. If you get paid monthly, make your mortgage payments monthly. If you get paid weekly, make your mortgage payments weekly. If you get paid every 2 weeks, make your mortgage payment every 2 weeks. If you get paid twice a month, make your mortgage payment twice a month. The reason for that is you do not want to miss a mortgage payment. And if you get paid on the first of the month, but you don't make your mortgage payment till the 18th of the month, you may have rather cavalierly gone through more of your pay than you should have. So you should make it so that if you get paid on a Friday, you make your mortgage payment on the Monday. That way you're not going to miss your mortgage payment. So I make bi-weekly payments. That means, of course, as you can guess, every 2 weeks, which, believe it or not, is not the same thing as semi-monthly. If we think about it, okay, if we think about payment frequency, okay, so payment frequency, and we're going to do number of pays per year. And I know that's miserable, but this is, you don't need to write this down. I just want you to have an idea. So if I say monthly, how many payments do I make per year? Well, I'm hoping you know it's 12. If I say it's weekly, I hope you know there are 52 weeks in a year. If I do it bi-weekly, bi-weekly means I do it every 2 weeks. So 52 divided by 2 is 26. And if I do it semi-monthly, how many weeks are in a month? Well, there are 4. And so you might think, oh, so it's bi-weekly is the same. It's not, though. There are 12 months in a year. If I do it semi-monthly, it means I do it twice a month. So it means you would make 24 payments per year. Okay, so bi-weekly and semi-monthly are similar, very similar, but the difference is that it really should align with when your payment happens. I get paid 20, well, I don't, but close to 26 payments a year is what my paycheck comes in. My wife gets paid semi-monthly, so she gets paid 24 times a year. So we have ours arranged to go with my paycheck. Okay, so I borrow 161,500 for my mortgage. I amortized over 20 years. That means that's how long the mortgage takes to get paid off. My interest rate was 3.4% per annum, compounded semi-annually, and I make bi-weekly payments. That's a huge amount of information. And trying to calculate these things by hand is super challenging. Okay, it really is challenging. However, on a TVM solver, it's not bad at all. So I'm going to grab this TVM solver again. Okay, and I'm going to reset it. Now, present value. So here's where it gets interesting. The present value of my mortgage is 161,500 because that's how much it started at, right? But it was a debt. So I owed it. So it's negative 161,500. So that's how much I owed. Payments is what I want to figure out. I don't even know if I wrote that in over here. Let's write that down. I make biweekly payments. What are my payments? Okay, so if I make biweekly payments, how much are my payments? So that's my question. So come back here. I owed 161,500 to start with. I have made payments. I don't know what they are. I'm going to figure those out. The future value. Future value, well, when my mortgage is paid off, how much do I owe? Well, I'm hoping nothing. So the future value is 0. The annual interest rate, I said it's 3.4%. So I'm going to come back here and it's going to be 3.4%. 3.4. Now, number of periods. Well, if I said it's biweekly and there are 26 payments per year and I do it for 20 years, so I can grab this and I can say 26 payments per year for 20 years. Okay, and it's 520. Okay, so I'm going to make 520 payments. So I'm going to come back here and I'm going to say the number of periods is 520. And then the compounding, we said it's semi-annually. All the fields are filled in. Oh, and I didn't say when. I make them at the beginning of the, so let's go back here and say the beginning. I make biweekly payments at the beginning of each period. Okay, so I make biweekly payments at the beginning of each period. So let's go back and figure out how much our payment is. Okay, so payment, boom. So I've made a mistake. There's no way that that is the right amount for the payment. Future value of 520, semi-annually compounding. Okay, welcome back. Sorry, I tuned out there because I thought I'd made a mistake. In reality, I'm pretty confident that there is a bit of an issue with how this is coded, and I just want to show you. So I'm going to take and we're going to do this as though it was in the calculator. So I said if we were at school, we'd be using TVM solver. So here is the TVM solver. This one's actually, the web interface one is actually nicer than the TVM solver on the calculator, but the calculator is at least done properly. So look, I've set this up pretty much the same way. So present value, negative 161,500, negative 161,500. Number of payments, 520, periods, 520. Interest rate, 3.4%. Interest rate, 3.4%. Payments per year. So bi-weekly is the same thing as 26 payments per year. So 26 payments per year. And the compounding periods per year is going to be semi-annually. So I'm going to go to semi-annually. And then I'm going to solve. So on this one, I solve, and I've already done it, but I go alpha solve, and it's $426.68, which is kind of what I expected. But when I click here, it gives me this wonky 2,700, and I know that's not right. So if I change it just to kind of, I was like, oh, what have I done wrong? And so I go down here, and if I change this to be 26, so it's most things default to have the same number of payments per year as the number of compounding periods per year. This one, I guess that's where this one, I think that's what it is. This one doesn't let you have a different number of compounding periods that it does as the payments per year. Because if I go and I solve this one now, alpha solve, $427.69. Go back down here to be, what was it, biweekly. and then I solve the payments, it's the exact same. So I guess that's the difference. So we do have a limitation here. My apologies, I didn't explore this ahead of time. I did some basic examples and they came out lovely. So I was like, oh, hey, this is what I need. So we're going to have to kind of cheat. We're going to always make it that just for this task, and I apologize, there isn't very many good TVM solvers online. It's one of the things that I think that I might get a computer science kid to try and implement. Nevertheless, so what we've got here is we're going to have to go that the compounding periods is going to match the payment frequency. I think that's what we're limited to here, which is unfortunate, but it still gives us an idea. So back to the problem at hand here, $427.69 is exactly what my payments are going to be. So I'm going to go back to this problem over here, and we are going to change this to be from compounded semi-annually. The compounded gets to be right. Actually, I guess you're going to erase it, I guess. It's not going to be compounded semi-annually. It is going to be compounded, same as what the payments are. It's going to be compounded biweekly. Okay, and I guess that because of this, we're going to have to restrict ourselves so that from now on, it's going to have the same compounding period as what the payment frequency is. So we found out that in fact the payments here are going to be $427.70 or 69 cents. So $427.69. So the payment is $427.69. Okay, so that is what the every 2 month payment is going to be. So apologies again for that mistake, but let's explore this. So this is actually really realistic. Like in fact, that's what my mortgage was set up initially. I've changed some things since then, and mortgages are amortized. That's how long they go for, but the length of your mortgage is different. Yeah, it's confusing. But let's think: how much interest will I pay over the life of my mortgage? And this can be a frightening number to calculate sometimes. So this is how big my payment is, right? I pay $427.69, and I pay it every 2 weeks for 20 years. So we already saw that I make 520 payments, and each one of these payments is $427.69. Okay. And so that means the total amount of money that I pay back to the bank. So let's go over my calculator here. Go out to the actual calculation. 520 payments of $427.69. Okay. So I make a total payment to the bank overall over the life of my mortgage. I pay $222,398. So 222,398, and I believe there was 80 cents at the end. So this is how much I pay the bank in total. That is the total number of dollars that over the 20 years I pay back to the bank. But my mortgage was only really I only borrowed 161,500. So the difference there is how much interest I paid. Remember, interest is the fee that I pay for the privilege of using. In this case, I'm paying the bank interest, so I'm paying for the privilege of using that money. So minus 161,500, which is $60,898.80. So 60,898.80, which seems like an insane amount of money. So that is the interest I pay on my loan. Wow. Okay. And I'll tell you, like 3.4% is actually a little bit higher than what mortgage rates are right now. But it's funny, mortgage rates are so low that the textbooks that we have don't actually go low enough in their charts. It used to be that we didn't have access to really nice calculators to help us calculate these things. And so we would use mortgage charts. And the mortgage charts, the lowest that when I first started teaching here 16 years ago, I remember I taught the finance course. The lowest the mortgage chart went to was 7%, because that's the lowest interest rate that had been seen in years and years and years. Where mortgage rates now are as low as, in theory, like 2.5, 2.4%, but 3.4% is still pretty low in the grand scheme. So over the life of this mortgage, I had to pay a total of nearly $61,000 interest, which just seems like a staggering number. Okay, so there it is. I'm going to put up some practice problems for you to play with, and that will be awesome. Okay, thank you.